So again, there's several ways to do this. One way is to list place values of base 2 until we get just past 46. So 1, 2, keep doubling, 4, 8, 16, 32, 64. Okay, that's too far. So I need up to 32. And then I see how many 32s do I need, and then I keep moving down the chain. So 32 goes into 46 once, subtract, I get 14, and I can see that although I need 132, I don't need any 16s because 14 is too small, so I'm just going to skip over to 8. 8 goes into 14, one time, 6 left over, and so I need 4. And again, in binary, it's either 1 or none. I need 2. And I don't need any 1s. And again, I didn't need any 16s. I don't want to forget that. So I needed 132. I needed no 16s. I needed 1 8. I needed a 4. I needed a 2. And I needed no 1s. You got to write a 0 or a 1 for each place. So again, I decided based on my powers of 2 that I needed 1, 2, 3, 4, 5, 6 digits to represent this number. 1, 2, 3, 4, 5, 6 digits. How can I check to see if I get it right? Besides hitting the submit answer button. Do it the other way or expand it to make sure it adds up correctly. So I'll do it both ways. I'm going to do it the other way. The other method I like is to start dividing by 2 right away. So 2 goes into 46. Let's see, 2 goes into 4 twice. 2 goes into 6 3 times. Remainder 0. And then you keep dividing into whatever you have as a quotient there. So 2 goes into 23, 2 goes into 2 once, 2 goes into 3 once, remainder 1. We just keep building up until we get a 0 at the top. 2 goes into 11, 5 times. Hit myself 5 times, remainder 1. Keep going. 2 goes into 5 twice, remainder 1. Color. 2 goes into 2 1 time, remainder 0. That's not the 0 I want. I need it at the top of the division. And then finally 2 goes into 1 0 times, remainder 1, and there's my answer. 1 0 1 1 1 0. So I have above, looking from top down.
So you said 2 divided by 2 with a remainder of 1.
Here,
Yeah.
2 goes into 2 once with a remainder of 0.
Oh, okay.
And then
So
2 goes into 1.
2 divided by 6 with the remainder of 1. And then you moved up to 2 divided by 2, which is 1. Where is the remainder 1 coming?
This stack right here you're looking at?
Yeah.
Okay, I'll just do it again. So 2 goes into 46 23 times with a remainder of 0, right? Because it's even. And then 2 goes into 23 11 times, and that's odd. That's going to have a remainder of 1, right? And then just keep going that way. 2 goes into 11 5 times. Sorry, it's 11 5, remainder 1. 2 goes into 5 2 times, remainder 1. 2 goes into 2 1 time, remainder 0. Right? And then finally 2 goes into 1 0 times. That gives me my last remainder,
Okay.
which is this one right there. And we read it.
We're trying to see how you went from 0 remaining.
Yeah, I still have this 1 here to deal with. I keep going until I get a 0 quotient. And quotient's the number above in long division. Quotient remainder. Yeah, so with this method, you continue till you get a 0 quotient. And when we divide like that, like 2 goes into 46, 23 times, remainder 0, this is my remainder, and the 23 is the quotient. Now, I could have messed either of these up. It could be wishful thinking that they both match. So I'm just going to expand it to make sure I got it right. So again, my places to check this, so that should be my answer. To check, I'm going to expand it. So to expand it, I have to remember that that top place was 30 seconds. So I have one, so I need a little more room than that. 132, and I have no 16s, and I have 1 8, and I have 1 4, and I have 1 2, and I have no 1s. So that's going to be 32 plus 8 plus 4 plus 2. So that's going to give me 10, 16, carry the 1, 1 and 3 is 4. Yep, 46. So I have the correct base 2 or binary numeral. Has anyone noticed that I use the word numeral sometimes and number other times? You guys know the difference between number and numeral? I don't think I've done a good job of explaining the difference.
Is it numeral more than one?
No.
It's like no, because I
So,
Roman numerals.
Here's the difference. Yeah, they're called Roman numerals. Yeah, so side note, number versus numeral versus digit. This actually is, it's technical, but it's important. Number is an idea. So remember I asked you before, what does number mean? And we said, well, it means like quantity. What does quantity mean? Quantity means amount. What does amount mean? Amount means number, right? Quantity. So I have the idea of 10 things, and I can show you 10 fingers, and I can show you 10 pennies, and I can show you 10 candies. They're all 10. That's the idea of 10 things. Numeral is the way we write a number. So for example, I'm used to writing 10 by putting a 1 next to a 0, and everybody I know recognizes that as 10. But some of my computer geeky friends would say, oh, you could write 10 as an 8 and a 2 and no 1. So this is 10 in binary. That's a numeral representing 10. If you agree, we're basing on 2s, not on 10s. We could write 10 in base 5. Or Roman numerals. Right? They're just different ways to note the idea of 10 things. What is 10 things? There's 10 things. Or sometimes we like to do this. Hash marks, you ever do that when you're counting stuff? That's 10. Right? I could draw 2 hands. This is the best artistry I have on the fly. There's 10, right? 10's an idea. When we write it down, it's called a numeral. What's the difference between a digit and a numeral? Digits are the individual symbols we use to write numerals. So in our number system, we happen to have 10 digits. The Mayans, they got away with 3 digits, even though they use base 20. It's pretty awesome. So number is the idea of quantity or amount. Numerals that we write down these ideas, that other people recognize them, and digit are the symbols we use to make those numerals. And back to the homework analysis.